What is an ice sheet? An ice sheet is a mass of glacial land ice extending more than 50,000 square kilometers. The two ice sheets on Earth today cover most of Greenland and Antarctica. During the last ice age, ice sheets also cover much of North America and Scandinavia. Together, the Antarctic and Greenland ice sheets contain more than 99% of freshwater ice on Earth. The Antarctic ice sheet extends almost 14 million square kilometers, roughly the area of the United States and Mexico combined. The Antarctic ice sheet contains 30 million cubic kilometers of ice. The Greenland ice sheet extends almost 1.7 million square kilometers, covering most of the island of Greenland, 3 times the size of Texas. Under their own weight. Near the coast, most of the ice moves through relatively fast-moving outlets called ice streams, glaciers, and shelves. As long as the ice sheet accumulates the same mass of snow as it loses to the sea, it remains stable. Why are ice sheets important? Ice sheets contain enormous quantities of frozen water. If the Greenland ice sheet melted, scientists estimate the sea level would rise about 6 meters. If the Antarctic ice sheet melted, sea level would rise about 60 meters. The Greenland and Antarctic ice sheets also influence weather and climate. Large high-altitude plateaus on the ice caps alter storm tracks and create cloud downslope winds close to the ice surface. In addition, the layers of ice blanket in Greenland and Antarctica contain a unique record of Earth's climate history. Has climate change started to affect Earth's ice sheets? The mass of ice in the Greenland ice sheet has begun to decline. From 1979 to 2006, summer melt on the ice sheet increased by 30%, reaching a new record in 2007. At higher elevations, an increase in winter snow accumulation has partially offset the melt. However, the decline continues to outpace accumulation because warmer temperatures have led to increased melt and faster glacial movements at the island's edges. Does this mean the future of our planet's climate is inevitably doomed? Well, we're going to cover some facts and some startling images from the media showing just possibly that might be the case. Melt season duration, melt onset, and freeze updates are derived from satellite passive microwave data analyzed from 1979 to 2005 over Arctic sea ice. Results indicate a shift towards a longer melt season, particularly north of Alaska and Siberia, corresponding to large retreats of sea ice observed in these regions. Although there is a large interannual and regional variability in the length of the melt season, the Arctic is experiencing an overall lengthening of the melt season in a rate faster than previously anticipated. In fact, all regions in the Arctic except for the Central Arctic have statistically significant longer melt seasons. In 2005, the Arctic experienced its longest melt season, corresponding with the least amount of sea ice since 1979 and the warmest temperatures since the 1880s. Overall, the length of the melt season is inversely correlated with the lack of sea ice seen in September north of Alaska and Siberia. The discontinuous permafrost zone of boreal western continental Canada, permafrost is limited almost exclusively to the ompotrophic peatlands. Permafrost in peatlands recently has been degrading and continues to degrade at its southern limit across western Canada, with no evidence of regeneration. The melting of permafrost could have dramatic effects on organic matter accumulation, organic chemical properties, and nutrient status in peatlands. Results indicate that peat chemistry may differ according to the presence, absence, or degradation of permafrost. Recent rates of organic matter accumulation follow similar trends over the past 100 to 200 years in the permafrost and continental bogs. However, net rates of organic matter accumulation are accelerated by 60% in the internal lawn. As decomposition in peatlands is influenced by nutritional limitations and organic matter quality, peat chemistry is likely to be a critical factor in the carbon balance response of boreal peatlands to climate change. The world population is the total number of humans currently living and was estimated to have reached 7.7 billion people as of April 2019. It took over 200,000 years of human history for the world's population to reach 1 billion, and only 200 years more to reach 7 billion. The world's population has experienced continuous growth following the Great Famine of 1315 to 1317, and the end of the Black Death in 1350, when it was near 370 million. The highest global population growth rates, with an increase of over 1.8% a year, occurred between 1955 and 1975, peaking to 2.1% between 1965 and 1970. The growth rate has declined to 1.2% between 2010 and 2015. and is projected to decline further in the course of the 21st century. However, the global population is still increasing and is projected to reach about 10 billion in 2050 and more than 11 billion in 2100. Total annual births were highest in the late 1980s at about 139 million, and as of 2011 were expected to remain essentially constant at a level of 135 million. While deaths numbered 56 million per year and were expected to increase to 80 million per year by 2040, the median age of the world's population was estimated to be around 30.4 years in 2018. In the mid-2019s, the United Nations estimated that the world population had reached 7.7 billion. 6 of the Earth's 7 continents are permanently inhabited on a large scale. Asia is the most populous continent, with its 4.5 billion inhabitants accounting for 60% of the world's population. The world's 2 most populated countries, China and India, together constitute about 36% of the world's population. Africa is the second most populated continent with around 128 billion people, or 16% of the world's population. Europe's 742 million people make up 10% of the world's population as of 2018, while the Latin American and Caribbean regions are home to about 651 million, 9% of total population. North America, primarily consisting of the United States and Canada, has a population of around 363 million, or 5%. And Oceania is the least populated region. It has about 41 million inhabitants, or 0.5%. Though it's not permanently inhabited by any fixed population, Antarctica is very small, fluctuating, and has an international population of about 1,000 people, based mainly in polar science stations. This population tends to rise in the summer months and decrease significantly in winter as visiting researchers return to their home countries. The Industrial Revolution began in Great Britain, and many of the technological innovations were of British origin. By the mid-18th century, Britain was the world's leading commercial nation, controlling a global trade empire with colonies in North America and the Caribbean, and with major military and political dominance on the Indian subcontinent. The Industrial Revolution marks a major turning point in history. Almost every aspect of daily life was influenced in some way. In particular, average income and population began to exhibit unprecedented, sustained growth. Some economists say that the major effect of the Industrial Revolution was the standard of living, for the general population in the Western world began to increase consistently for the first time in history, although others have said it did not begin to meaningfully improve until the late 19th and 20th centuries. GDP per capita was broadly stable before the Industrial Revolution and the emergence of the modern capitalist economy, while the Industrial Revolution began an era of per capita economic growth in capitalist economies. Economic historians are in agreement that the onset of the Industrial Revolution is the most important event in the history of humanity since the domestication of plants and animals. Although the structural change from agriculture to industry was widely associated with the Industrial Revolution, in the United Kingdom it was already almost complete by 1760. The precise start and the end of the Industrial Revolution is debated amongst historians, as is the pace of economic and social changes. Industrialization first began in Britain, starting with mechanized spinning in the 1780s, with high rates of growth in steam power and iron production occurring after 1800. Mechanized textile production spread from Great Britain to Central Europe and the United States in the early 19th century, with important centers of textiles, iron, and coal emerging in Belgium and the United States, and later textiles in France. An economic recession occurred from the late 1830s to the early 1840s when the adoption of the original innovations of the Industrial Revolution, such as mechanized spinning and weaving, slowed and their markets matured. Innovations developed late in the period, such as the increased adoption of locomotives, steamboats, and steamships, hot blast iron smelting, and new technologies such as the electrical telegraph, widely introduced in the 1840s and 1850s, were not powerful enough to drive high rates of growth. Rapid economic growth began to occur after 1870, springing from a new group of innovations in what has been called the Second Industrial Revolution. These new innovations included steel-making processes, mass productions, assembly lines, electrical grid systems, the large-scale manufacture of machine tools, and the use of increasingly advanced machinery in steam-powered factories. I guess the real question is whether or not, as a society, that we believe climate shift is happening or normal. But I have some dialogue here that says over the past 2,000 years, scientists just haven't seen anything like it. Over the past 2 millennia, the world's climate has gone through its fair share of ups and downs. What is happening right now stands out in stark contrast. 2 new papers have demonstrated the peak warming and cooling events before the Industrial Era, such as the so-called Little Ice Age and the Medieval Warming Period, were vastly smaller in scope than today's global reach of human-induced warming. Using a robust database compiled from almost 700 proxy records of historical temperatures, including tree ice, sediment, corals, cave deposits, and documentary evidence, the authors of these 2 papers have woven together a nuanced global picture of climate change since the time of the Romans. The main takeaway is that climate variability in the contemporary period is very different to what's happened in the past 2,000 years. The warm and the cold in the past were just regional, whereas we see now it's global. These new findings, based on 7 different statistical techniques, provide a much clearer historical context for the current climate crisis. While it's widely thought that events like the Little Ice Age occurred simultaneously across the globe, an exhaustive analysis published by Nature magazine has not found any evidence for this claim, not in climate model simulations, not in global reconstructions, or in proxy data. Looking at temperature trends year by year across the entire planet, the authors of the climate studies have shown instead that the coldest epoch of the last millennium occurred at different times, in different locations, and in less than half the globe. The Central and Eastern Pacific Ocean, for instance, experienced its coldest peak in the 15th century, whereas Europe and southeastern North America was not hit from this cold front until 200 years later. When we look at the warming events, even in the medieval warm period, otherwise known as the medieval climate anomaly, the authors show only 40% of the Earth's surface reach peak temperatures. Among these natural climate variations, the modern and industrial area sticks out like a sore thumb. It's by far the warmest period in the past 2 millennia and is occurring almost everywhere, in more than 98% of the globe. Around 4,000 years ago, the advanced urban civilizations in Egypt, Mesopotamia, and India suddenly collapsed. What happened? Did a prolonged drought cause a breakdown of social disorder? Recent discoveries suspected link of the collapse of the climate. It appears that a major shift in the precipitation pattern affected many parts of the world approximately at the same time, with disastrous effects on the nomadic populations of Asia, Africa, and Eastern Europe. Can a similar climate shift with a serious adverse impact on society happen again? In a world facing global warming, there can be many lessons learned from the experiences of ancient societies. Free energy suppression, or new energy suppression, is a conspiracy theory that technology-viable, pollution-free, no-cost energy sources are being suppressed by the government, corporations, or advocacy groups. Devices allegedly suppressed include perpetual motion machines, cold fusion generators, torus-based generators, reverse-engineered extraterrestrial technology, and other generally unproven low-cost energy sources. The alleged suppression or weakening is claimed to have occurred since the mid-19th century and allegedly perpetrated by various government agencies, corporate powers, special interest groups, and fraudulent inventors. The special interest groups are usually claimed to be associated with the fossil fuel or nuclear industry, whose business model just might be threatened. Claims of suppression include the claim that the scientific community has controlled and suppressed research in the alternative avenues of energy generation via the institutions of peer review and academic pressure. The claim that devices exist which are capable of extracting significant and usable power from pre-existing unconventional energy reservoirs, such as the quantum vacuum zero-point energy, for little to no cost, but are being suppressed.